Okay, so I'm pretty used to getting people to listen to security after lunch, but you guys look really sleepy, so maybe just stand up and stretch for a minute, or just stretch in your places, that's also fine. Okay, so I'm here to talk to you about serverless security, and we'll try to do it fun because it is, I guess, after lunch and you are tired. So we'll do a few examples and we'll learn from these examples, and then we'll go through a live demo if everything will work properly. So first of all, about me, my name is Segal. I'm the CTO and co-founder of, I guess, what used to be PureSec up until 2 weeks ago. We got acquired by Palo Alto Networks. Thank you. Let's try that in 3 years when I when I finish my tenure there. I've been involved in the AppSec industry since the late 90s, working on the research of some cutting-edge products. The world's first web application firewall called AppShield from Sanctum, if anyone remembers that. And then IBM AppScan, and after that, Akamai cloud security products, mainly the web application firewall and client reputation. These are some of the white papers that I published, the research papers. There's one that I like to show off, although it sort of gives up my age. So I found a remote code execution in Apache back in 2002, where I was already late in my 20s. Yeah, let's continue. More importantly, I'm also the guitarist and the co-founder of an Israeli art rock band called Pitts. You can download our music there if you're into noise kind of stuff. So let's start with serverless security. We'll go very quickly about some security concepts. What am I actually referring to when I'm saying serverless security? And then we'll see some of the pitfalls and a few examples, and we'll do the demo, which should be really cool. So first of all, just to align on the terminology, what is serverless security? When I'm saying serverless security, some people hear different things. If you look at the shared responsibility model that we have in any kind of public cloud model, the cloud provider is responsible for part of the tasks and or the security, and the application owner is responsible for the rest. When it comes to serverless, it really reaches new heights of, I guess, the responsibility for the cloud provider. We'll see that in a second. But in essence, the cloud provider is responsible for everything from the physical security, so the guards, the locks, the passwords, the doors, the server racks, all the way up to the security of the container that is running your serverless functions. And you, on the other hand, are still responsible for the application layer itself. And in serverless, the application layer is mostly the functions, as well as the configuration of the different cloud services and the data, of course. And we'll get back to that in a second. Now, what does this split in responsibility actually mean in terms of security? So if you look at traditional world infrastructure as a service or hosted VMs, the cloud provider is pretty much responsible only for the security of the infrastructure itself, and maybe the compliance, PCI or HIPAA or whatever they comply with of the infrastructure itself. And you, as the owner, are pretty much responsible for everything else, from testing the systems and patching it and hardening the operating system and so forth, all the way up to the application layer. When you switch or when you adopt to serverless, things change dramatically in your favor, actually. And usually this is not very popular for a security expert to come and talk about security and not frighten you, but give you, try to encourage you to adopt serverless. So it is correct. When you adopt serverless, you are starting at a much better starting point from a security perspective. So you are now responsible for, and the list here doesn't really matter, but approximately only 50% of the tedious day-to-day chores that you have to run for security, and the cloud provider is responsible for a lot more. So everybody talked about serverless. I'm going to go very quickly over this because I'm going to use the same slide up next. So a developer pushes code, deploys it to the cloud. You tie it to event sources. The event sources trigger your function. The function does something. Usually it's not isolated. It will interconnect with other cloud services. And sorry, if everything's okay, it will generate some output. So how can an attacker even access your serverless functions? And many people think that they are internal or they are running internal workloads and they're not accessible to the internet. So we see 4 main paths for an attacker to reach your actual business logic. And assuming the attacker is an orange guy or a faceless guy, we start with event data injection. Events are what triggers the function. The events bring in data. Think about an event, for example, an HTTP trigger. The event includes the parameters, the cookies, the path, headers, etc. Some of these are controlled by the users, and so an attacker can manipulate them. So that's one type of attack. We all know about SQL injection and cross-site scripting and path traversals and all of those. It's easy to understand when we're talking about an HTTP trigger, but how do you think about it when we're talking about an S3 event or an SNS event? Different fields are controlled by the attacker. Up next, unauthorized deployment. So there's a wide range or a spectrum, to draw on my previous presenter, of attacks that you can actually run, like a cross-site scripting against a developer or a phishing attack, spear phishing attack, steal credentials, and then deploy code directly into the cloud, not through the code repository. Less far-fetched is poisoning dependencies, and we actually saw this a few times in the past year. It's a very interesting trend that we're seeing, where malicious actors will poison open source libraries, plant all sorts of code that does things like, I think the last one I heard was Bitcoin mining through some NPM package. And then when you use the NPM package, it basically runs that code in your Lambda environment or runtime environment. It's not very different than traditional applications. However, your ability to detect that is degraded. And last but not least, tampering with the data in those cloud services that the functions interact with. Easiest example, and I'm sure you all know, S3 buckets that are publicly open, and we'll see that in a second. What can an attacker actually achieve from these types of attacks? Pretty much everything you know from application layer security, compromising data, abusing the business logic, authentication bypass, and so forth, with some twists, specifically around denial of service, where it becomes more of a financial impact for you. Somebody can hog the application, deny other users from using it, and inflict some serious financial damage. I'm not going to go over the entire list of top 12 risks. We actually published this earlier this year. This is a refresh of last year's Serverless Top 10. This is a project that PureSec did together with the Cloud Security Alliance. I urge you to download the white paper. It's really long, and it touches on not only on the problems, but also how you can mitigate them, and touches upon both AWS and Google Cloud Functions and Azure, etc. Why am I actually here talking about serverless security? Why is it actually different than standard application security? Usually people ask me, okay, can't I put a web application firewall in front of my app? So if you look at traditional security solutions for application layer security, you see that they require you to deploy something on the infrastructure, either on the host or on the network. And in serverless, you're not in liberty to do that. You only control your code and your configuration. So those traditional security solutions are becoming unsuitable. Think about an application, as we will see in a minute in the demo, that uses emails that trigger Lambda functions. There's really no place for you to deploy a web application firewall. In many cases, we're talking about cloud-native environments where we're talking about cloud events triggering functions, and there's really no place to put a web application firewall in there. And to put it into some graphics, if we take an application today, in order to give it like an end-to-end security, we'll start by deploying an endpoint protection solution on the host to detect malicious behavior, and then intrusion prevention on the network, web security gateway to inspect malicious outbound traffic, next-gen firewall, and of course a web application firewall, and we put all of that on the infrastructure. When we go serverless, we break the application into functions, we deploy them to the cloud directly, and just as our users can eventually trigger those functions, so can attackers. And without any barrier or any kind of runtime protection, the security of your application boils down to, or is reduced to, just how well you wrote the code and how strict your configurations are. We're okay? You look a bit tired? Great. So we'll start. The first topic that we're going to touch upon are IAM, Identity and Access Management. We'll get back to some funny examples in a second. But serverless functions, or when you break something into microservices, you want to grant every microservice the least required privileges. And I'll demonstrate in a second why. The way to do that, for example, if you have a function and the function, or the developer is using dynamo.putItem to insert items into the table, we should only grant the function that exact permission, something that we couldn't really do in traditional applications. However, the AWS and now the Google and Azure IAM role model allows us to very granularly define that. That is very hard. Well, it's easy to understand and to do when you're dealing with one function, but when you're doing it with a full app that has dozens, if not hundreds of functions, that becomes a nightmare. And so the human factor then plays a role, and most developers, or not most, but at least from what I've seen, 21% of the projects that we scanned on the internet had this problem where developers use wildcards or an asterisk, which means that you grant the function all of the permissions for everything that Dynamo has to offer. By the way, if we want to use dynamo.putItem, can anyone name the actual name and spell the actual permission you need to grant? Speak out louder. And how do you spell it? So camel casing, yes. Yeah, so it's not that easy, and it's not always one-to-one or straightforward. You have to actually go to the documentation and check it out. Another way is to fail the IAM permission check and then see what you need to add. By the way, when you do add an asterisk to a function, you're basically creating a colossal catastrophe, which means that the function is allowed to do all of these things, some of which are obviously not what you intended the function to be able to do. And why do you need that? And we'll see again, we'll see it in a second. It allows you to contain the damage in case something bad happens. So these are among the most common issues, at least based on what we've seen. And as I said, if you are able to create a function that is very focused in what it needs to do, and also has the best or the most strict or least privileged permissions, this works like bulkheads in a ship or in a submarine, where if something explodes, everything is very contained to that specific function. And that could be very frustrating to an attacker, and perhaps what will save your life, as you will see now in the demo. Not in the demo, in the story. So if you, last August actually, a friend of mine called Caleb Sima created this website called lambdashell.com, and he offered a $1,000 bounty to whoever can cause some serious damage to his AWS account. He basically created a Lambda function that gives you a shell terminal over the web, so you can type whatever commands you want. In any other type of web application, I would say this is game over. This is pretty much the holy grail for what an attacker looks for. Remote code execution is the highest thing you can want. So we saw that, and obviously we thought to ourselves, that's great for PR. If we can hack this application, we can cause some damage, we can get some really nice PR for PureSec. And so we accepted the challenge. The first thing we've done was to use that web-based terminal to run the env to get the environment variables out of the Lambda environment. And we noticed those 3 session tokens that I will show in a second when the STS service assumes a role for the function. It gets a session, basically 3 tokens, one of which is the session tokens, and then there's the secret key and the access key, if I'm not mistaken. So what I've done is I took this MAC, and I took the 3 tokens, and I exported them. I basically set them on this MAC, which would hopefully allow me to impersonate the Lambda function as it executes. So I am able to run the AWS CLI on my Mac, impersonating the role that the Lambda runs with, which is very awesome because I can. It's much easier to run the attack on my Mac than on Caleb's very ugly web interface. So I've done that, and I ran get caller identity, and I actually got what I wanted. So I was running as the Lambda role. And this is how I looked when I've done that. And I was like on the moments away from opening a champagne bottle and celebrating the fact that we hacked the system. And so I said, okay, now that I have the role, let's start using the CLI and getting some data back. And the first thing I did was to list the functions, and I got an access denied. And then it dawned on me that maybe Caleb wasn't as stupid as I expected, or as reckless as I expected. And so I tried a few different things, and I kept getting access denied on everything I was doing, which was very frustrating because, as I said, there I was impersonating the Lambda role remotely with a remote code execution on an application, unable to do anything, which exactly boils down to what I talked about a second ago. You have the worst case scenario with good permissions, you're very limited to what you can do. And so that took, I think, a couple of days of trying more and more things, and everything failed, and this is pretty much how I look like. And then I said, wait a second. Usually when there's a website, the static files are stored in an S3 bucket, right? And usually what you do is you give that S3 bucket the domain name. That's the name of the bucket. And so I tried that. I ran head bucket just to see if the bucket exists, and I got an empty response. And this is why I'm scratching my head there. And then I started thinking, wait, does an empty response mean the bucket exists, or is this like a quirk that's going on? And so I tried a completely different, name of a bucket that obviously doesn't work, doesn't exist, and I got a 404. And then it dawned on me, yes, the bucket exists. Maybe I can do something. Now, keep in mind that the bucket is not publicly open. I'm running as the Lambda role. So the next thing was to do, I wanted to do was to list the contents of the bucket. And so I ran list objects, and I got the contents of the bucket, and I saw the different file names, one of which was index.html. And I said, okay, if I now need to prove to Caleb that I hacked his website, which I haven't until this point, I need to write something to the website. Maybe I'll create a page, and that will prove that PureSec was there, like you do graffiti. And so the first thing, maybe I was drunk, I don't know. The first thing that came to my head was, let's delete an object. Let's delete the index.html file. But yeah, that's especially stupid. Because I got an empty response. And as we know, an empty response means that the shit hit the fan. And so the next thing I know is I got a call from Caleb saying that the site is down. And Caleb was in Vegas. It was around the time of Black Hat last year. And so the site was down for 5 days, which wasn't nice on my part, but did allow us to be the sole winners, and all of our competitors or anyone else couldn't reach the site, which was really awesome. And we did win the bounty, and I still haven't received the $1,000 check. I'm not expecting this to get here. Thank you. How are we with time? Just so I'll arrange with the demo. Okay, so how do you get IAM permissions right? The first thing is you need to adopt a role per function model, and Jeremy's here in the first row and will probably agree with me that it's nice in theory, but you don't always have the choice. And in some cases, there's actually a limit of how many roles you can have in an account, if I'm not mistaken, or a region. So it's not always possible. Marcia, maybe you know. But you should strive to adopt a role per model, because it does mean that you end up with a least privilege if you follow all the rest of the instructions or recommendations. So always think twice before you use an asterisk. Sometimes you can't. There are services that require you to use an asterisk. It's not bad, like SES, if I'm not mistaken. But before you do that, think twice. If you can, and if you're using SAM, use SAM managed policies. There are two ways to do that. The wrong way, which is like this, granting full database privileges, and then the right way, which is, or the slightly better way, to use the CRUD policy. And if you really want to go the extra mile, then you can actually use the specific, or you should use the specific actions and resources in your configuration. There are some plugins that can help you. There's a plugin to allow you to, a serverless plugin that allows you to do a role per function. And there's also the PureSec list privilege IAM role generator. It's basically a static analysis scanner, scans the code, understands which APIs you're calling, and then generates a role for you automatically that is least privileged. It's open source, so you can download it, and it's not like I'm making any money out of it anymore, so feel free. Next example, RDoS, and this is going to talk about RDoS vulnerabilities and third-party libraries. How many of you know Corey Quinn? So Corey runs a mailing list, which is very sarcastic. He's a very sarcastic person. And getting his attention took a while. I wanted to prove to him that PureSec has something to offer to the world, and that serverless security is indeed a problem. And we started talking, and he said, I have this mail subscription Lambda as part of my application where people come to subscribe. Try to hack it, and if you will do some damage, I promise you that I will help you generate a spike in traffic that will be seen from outer space. Those were his words. He did mention that it doesn't do a lot, and the chances that we'll find something are very slim. But we tried. And so he actually gave us the code, which was fun. So we reviewed the code, and we saw he's using SendGrid to send and receive emails, and then SendGrid uses the Python email package, and at some point takes the user's email directly, turns it into an object. And we noticed, digging through the Python package, that the Python package supports RFC 2822, if I'm not mistaken, that discusses, among many other things, long format emails where you have the name and then the email. And I keep saying that, but usually when I see that the parser is involved, I know that there's good chances that there's going to be some fun involved here. And so what we've done is we started playing with funny-looking emails, again, based on reviewing the code and understanding that something's fishy going on there. And when we use this email, which obviously looks like a very legitimate email, the functions, or the package stalls for a few microseconds. And the larger the email address got, the longer the period it was stalling continued, to the point that when we hit 100 kilobyte, it was about 3 to 5 seconds. It's not always the same. It's not consistent. So if you think about it, it's not really a serverless attack, right? We managed to get the email parsing to stall for 5 seconds. So how is this really relevant? So if you post this 1,000 times to his web application, it hangs, and it hangs for a few minutes, which is very surprising, and nobody can register in that period. And all it takes is this Mac and a very small shell script, like a bash script, to do this. And so, just as a lesson, just so you know, Lambda by itself is not automatically DOS or denial of service resistant. You still have to think about your design and the flaws and weaknesses and what happens and how do you handle malicious input. I think I'm going to jump over the last, sorry. This is how it looked like when it failed. And for 5 minutes, nobody else could reach, or subscribe, actually. And Corey was true to his word and published a few things, caused a really nice spike in our traffic. Never got a single deal out of it, but it was worth the effort. So that's another one. I'll quickly go over this. We've found this Node NPM library that somebody created to help you with multi-part parsing. How many of you know multi-part, HTTP multi-part? Yeah, it's pretty simple. The way a multi-part request works, you have a post request, and then instead of having the parameters normally in the body, you create parts, and for each part, you start the part with a boundary. And what I noticed looking at the code, and again, this is not an AWS vulnerability, this is somebody's NPM package. I noticed that the regular expression they're using to split the boundaries, or the message by the boundaries, uses the user's input directly as the regular expression. Big mistake, because this is the boundary that I sent, which is the worst case scenario regular expression you can create. And again, this stalled for minutes. So sending 1,000 of those, 1,000 concurrent executions, the account is saturated and nobody can access the site. Here's the part you all been waiting for and that I dread every time. So let's see if I can do this. I do need to get my screen to work normally because now I see something else here. This is a new computer, so yeah, it's a Mac. Go ahead. Do whatever you want. I know how to hack, not how to switch screens. And it's the first time I'm using Keynote, so I think that has to do with that as well. Just go to screens. You're giving away all the secrets.
I know.
There it is. Just mirror displays. Yeah, great. Now I need binoculars to see, to see the screen. I'm just kidding. Okay, so I'm not going to switch back. We'll do it this way. I have a serverless application. It's an HR. Can you there's no way you can see this. This is an HR application that helps the HR team. Our HR actually came up with this idea to filter through candidate CVs, resumes. The way it works is the candidate will send an email. The email will contain the CV, the resume as a PDF. The Amazon Simple Email Service will grab that. That's fully managed email service. Pass it through the SNS, through an SNS message to Lambda. Will trigger the Lambda function. The role of Lambda in life here is to extract the attachment, turn it into plain text, run our candidate qualification analysis algorithm on the text, store the results in a DynamoDB table, send an email back to the candidate that we are working on it, and expose a web interface for the HR team. And this actually works and does what I just mentioned. I always say that if PureSec wouldn't have worked, I would be able to sell this because it's really cool. But things turned out differently. So how do we actually operate this application? And I'll zoom whenever you need to actually see the letters. We'll start by sending an email. So I'll send an email to the HR team. I'll call myself John Smith. My CV is attached. And we'll attach the CV. And it's just a regular PDF. There's really no malware here. And we'll send it. And it will take about 10 seconds to go through the cold start and all the analysis. And now it goes through SES to SNS to Lambda, triggers, parses, stores. And in about 2 seconds, we'll see their reply email back. There it is. And so everything's working, the system is working, and now indulge me for the sake of the story, let's say I didn't get accepted to the job, and now my sole purpose in life is to get revenge with that company, and the way I will do that is I'm going to leak their entire database of sensitive candidate information to the internet and sell it or do whatever with it. So how do we do that? And if this was a web application, I would have some web forms. I would probably spin up a SQL map or some fuzzer and start hammering. But this is an email message. I'm not going to do that. And I certainly don't expect the developer to be that reckless that I will type some malicious or bad characters and I'll get a stack trace back over the email. That's not very likely. So I need a different approach. How do we do that? We'll send another email. And there's pretty much only two places that I can control. One is the contents of the PDF file, and the other one is the file name itself. And it's safe to assume that the system is using the file name to copy it, to extract the content. So we'll run the attack from here. I need 2 minutes. That's good? Okay, so let's party. So what we'll do is we'll copy the file. It's the same PDF, and we'll change the file name. And this time I'm going to change it to John, semicolon, sleep 5000 hash. It's a very nice family name. We all know the little Bobby tables, right? So what is the logic behind this attack? And attackers, or if you're running pen tests, you know this as time-based probing. Since I'm not expecting the system to send me back a stack trace, I need to sense somehow that it is vulnerable to command injection, that my commands in the file name are running. How do I do that without debug prints? I'm going to use semicolon to start a new command, if that works. And then sleep is going to sleep for 5,000 seconds. It's going to time out. So it took about 10 to 15 seconds for us to get the reply email when everything else worked. Let's see what happens when we do that. If I'm not going to get anything back, that's going to be our signal that the system is indeed vulnerable and that the malicious payload should be sent as a part of the file name. So I have 7 minutes, but we're not going to wait the 5,000 seconds. I can talk for another 10 seconds so you'll believe me. But now we know that the system is vulnerable to shell command injection through the file name, but we know nothing about it. It's an entire black box for us. We need to somehow understand how the system works if we want to get revenge. So how do we do that? We'll type another email. And this time, I'm going to use a slightly different payload, which looks like this. But I want to show you first what this payload does. So I want my payload to steal the source code of the Lambda function and send it back to me. How do I do that? I use the code execution first to get the name of the Lambda function. That's easy. That's simple Python code. And then I open the file and I pour the source code back to a reply email to me. Now it's all nice that this is sitting in paste bin accessible to the internet, but how do I get it into Lambda and to execute it? And that's what we're going to do here. So this is the payload, and what it does, instead of semicolon sleep, it does semicolon basically curl to silently fetch the data from paste bin and then pipe it into a Python 3 child process. So it looks simple, but it took a while to get the encoding working. And obviously, that ends with a .pdf because this is a very legitimate PDF file name. And then I need a subject. Usually I do that in the next one. And what happens now is very interesting because the function is going to run. It's going to extract the contents of the PDF, and then it's going to do the semicolon, curl, fetch the data from pastebin, run it, get the source code, send it over email back to me. Pay attention to the fact that we didn't violate any IAM policy here. The function is allowed to read its own source code, and it is allowed to run Python, and it is allowed to run curl and send data or get back data from the internet. And so it is still running, and if we look in CloudTrail or in CloudWatch, you won't see any traces to the fact that somebody just leaked the source code. And again, this is not a vulnerability in the infrastructure. Lambda is working as expected. It's the developer who made the mistake that you will see in a second. So let's take a look at the source code. Now it's not a black box engagement. We can learn what the function does. So there's some table name defined. That's very good that it's not defined. It's not hard-coded. It's an environment variable. However, as you will see in a second, we can just reuse it. And we see it's a DynamoDB. There's a client here. This is the function itself, reading the SNS message, getting the payload, getting the file name. Good security practice, checking that it ends with PDF, right? That's classic, which is why I use the hash sign.pdf. And here's the big mistake. The developer is using a very common tool called PDF to text, which he or she compiled and uploaded to the runtime environment together with the Lambda package, and embedding the file name of our attachment directly into the command. So trusting non-trustworthy user input, big mistake. And then when we run the sub-process, we can split the command into two, the developer's original part and our second part. And here's the fun part. This is where the developer inserts the data into the table, and this is exactly the table that we now want to extract. How do we do that? And again, another mistake on the developer's side. I'm creating another file, again, storing on paste bin. It looks slightly different. I'm creating my own Dynamo client, and then I'm trying to call dynamo.scan, which Marcia said not to do, to scan the entire table. I have time, I'm not worried. Which table are we calling? I don't know, I don't care. I'm reusing the environment variable, very convenient. Then we dump the response and send it over email. And how do we do that? We compose an email. This time it's a real ha ha ha. Always wanted to do that. And slightly different, not here. Yeah, just wait a second. Wrong screen. There it is. You worried? It's going to work, I promise you. 10, 15 seconds, we'll get the entire dump of the database, and we're done. Two fatal, colossal mistakes. One, trusting user input, obviously running or using user input inside shell command, which is the worst thing you can come up with. And by the way, I have seen things like that. I can tell you horror stories later on. And then bad permissions. Back to what we talked about earlier. We had command injection here, or OS command injection. I was supposed to only be allowed to put items into the table, but I was allowed to also scan the table. Here's the entire database. Oh. So, I have to end it with something positive because I'm not here to scare you. Remember, if you do serverless, you're starting at a much better application security starting point than with the regular applications. I'm not here to scare you. I'm here to scare you from making mistakes. 4 actions, I think. 1, please download and read the 12 most critical risks paper. We and the community, and there's a bunch, Jeremy was also a participant, spent hours and days working on this. There's a very fun project called OS Serverless Goat, which is an application that's vulnerable, very similar to what you've seen here, which you can play with. It's a single-click installation in the app repo, in the AWS app repo. You can hack it, you can practice on it, you can learn how to protect, and you can brag to your friends that you know how to hack serverless applications. There's another free library called Function Shield that we contributed to the public that works on Google Cloud Functions and AWS and allows you to do 4 things. It's a behavioral protection library. You can disable outbound traffic, disable child process execution, disable the ability to read the source code of the function. And what was the last one? disable access to the file system so people can't write and read from /tmp. And last but not least, that least privilege CLI tool that I mentioned. So you can run it on your code. It will understand what the code is trying to do and generate an IAM role for you. We're done, right? If you have questions, I'm going to be at the back of the room. I don't want to hog the podium. Thank you.